Hey YouTube, it's JP Dillon. Welcome to part 2 of the Sony KV-1997r. This is the chassis which I have removed from the set. And if you go back and watch the first video, we had a logic problem that was preventing the set from turning on or remembering anything. So we have to look at various parts of the set. Many people suggested, who were in the service field at the time, to check for leakage in the tact switches, many of which we had to clean because they were misbehaving. We also need to take a look at the 5-volt lines that carry information, data, and the reset lines, because the microprocessor doesn't seem to be releasing from the reset. So I pulled the chassis out. Everything is very accessible. This is very easy to remove from the set. Everything unplugs. All I had to do was discharge the CRT, which was simply done with the screwdriver method with a jumper to the Aquatag. So very easy to do. So let's take a look at the schematic. And I was very lucky to find the actual service documentation, which is not easy to locate. I dug around a bit. It wasn't like one of those, hey, I bought this on eBay kind of thing. I had to kind of search the internet for it somewhat, and I did find this. So that makes me happy. So this is our microprocessor control here. And we need to pay attention to the reset lines. They're marked in red, as well as the test lines here. And so they have a reset control circuit with a reference voltage up here. They have a reset discharge capacitor here on that line, which is on the tuner, or excuse me, the video display IC. So this needs to be checked, because if this capacitor is defective or shorted, that would keep the line in reset. It's basically tracing out everything until we find what the culprit is, and it's really kind of a pain. We are going to measure the resistances of the tact switches, as mentioned before, because that is important. If any tact switch fails to release fully and there's a leakage path, that will interrupt the microprocessor, and that will keep it from doing what it needs to do. There should also be somewhere a memory control, either a supercapacitor that holds a charge or a battery or something. I'm probably aiming more towards the supercapacitor, which I've not yet found, but that would definitely, that and the reset problem could both cause the loss of memory. And it's also important, in addition to the reset, that all your voltage control lines, the 5.3 volt line there for your VCC, is absolutely clean, because if it's not, you're definitely going to have issues with microprocessor operation and such. So in this case, this is the microprocessor, this is the video processor, and C120 controls the reset buffer, which is kicking around here somewhere. Yeah, C120, that's your reset right there. So if that capacitor is shorted or open, that would cause a delayed or non-functioning reset. Any of these element capacitors, which are never in that great a shape, could always cause that. I don't see any giant memory capacitor here, although that doesn't mean it doesn't exist. Definitely a lot more checking and cleanup to do on these boards. But it would be like a 0.47 farad at 5.5 volts or some such thing like that. Might look over the previous work of Herman and company that was in here. But just for grins and giggles, let's give this guy a test and see if he's either shorted or open, and then we'll definitely ohm out all the tact switches and see where we get from there. So from a standpoint of ESR, it measures what about you'd expect for a 4.7 microfarad. From the standpoint of resistance, it's measuring 1.1406 kiloohms. And since there's nothing of that nature shunting that device with that resistance, I kind of wonder why it has such a low resistance. And we're just following this line and seeing if it goes to anywhere that would be considered a 1 kiloohm load. That's going to go off the page. And that's your 5 volt supply reference there. But again, So there's our R508, which is on the other side of a transistor. So I wonder if C523 is shorted to ground. Of course, that would mess with our 5-volt supply, wouldn't it? And then we wouldn't have much of any microprocessor. But out of curiosity, since that would be a line across that 68 ohm resistor there, plus the 1K, that would be close to 1.1K, wouldn't it? Yeah, curiouser and curiouser. So there's C512. That's the capacitor in question. Let's see if it's shorted. So across that capacitor, we only have 440 ohms. So that could mean that either the capacitor itself is defective, or the Zener diode, which is in parallel with it, is defective. And that definitely would piss off the voltage there. Now C224 probably isn't shorted, because if it is, that would definitely mean that there would be less than 1K there of resistance. But since the 68 ohm shunts that regulator there, basically you could be reading through that and the 1K. So that would be 1068 ohms, and then another 400 would be, 1500 ohms. So, I don't know. We need to lift one side of that capacitor and make sure that it's not buggered. And then, you could have C541 there, because that's in line with that 18 ohm 2 watt resistor there. But then we're starting to add up here. This is all kind of strange stuff. We could take a look at C. Let's see, we did 512. All right, so I was actually looking for 523. But 512 doesn't seem right either. It should be much higher resistance. At least that's what you'd think. All right, so C523 is hiding in a completely different part of the set. And so when I take my measurement across it, I get that 1.2K thing again. So let's lift one leg of that capacitor. So with that leg of the capacitor lifted, we get the same reading. And yes, I measured the resistance between the capacitor lead and the solder pad, and it is open, so I am measuring across the capacitor. The capacitor measures almost infinite, which is what you'd expect. But that line there, if you go from the solder pad to ground, is still about 1K. The regulator transistor Q507 seems to measure normal. We've got the low resistance between collector and emitter, which is what you'd expect, because there's a 68 ohm resistor in parallel with it. So I'm not really, I can check this one, but I don't think that's it. And it could be that there's something going on in the line, and we just have to, troubleshoot that a little bit further. But although my suspicions was that thing, I don't think that's it, unless the 5.9 volt or 5.7 volt Zener diode is only a K. Just seems odd, And if I lift the Zener diode, measuring the Zener diode, I get infinite resistance, and it checks out as a diode. More curiously, the 5 volt line here at the emitter of Q507 is only 160 ohms off ground. That seems like really, really low. So we're going to check 224 real quick. And lifting 224 doesn't change anything on that line, so we need to examine more stuff going down that line and just trace that line out and start removing loads until the resistance comes back, because I think that's what our issue is that 5 volt line should not be so close to ground. So I did check the resistances on the tack switches. The ones for the volume control were 69K. Picture up and down were like 5 meg. Channel down was 5 meg. Channel up was 5 meg. But when I got to the power, I noticed that when I pressed the power button and released it, the resistance across the switch was very erratic. So definitely we need to check the switch out of circuit and we need to take a look at what's going on that line. Could be two related problems, could be not related problems. But like the low resistance to ground on the 5-volt line concerns me, and the power switch concerns me. Now here's another weird thing. What happens if we connect our meter to ground and across the switch, and is that 5-volt line in that switch associated with it? No, I don't think so, because when I measure between the trigger side of that switch and the 5-volt supply line, it's several megs, so that's not it. But definitely the change in resistance when I hit the switch and when I don't hit the switch, that's of concern for sure. So that switch could be bad, like other people suggested, because it's only about 47K off ground at any given time. Sometimes it's as high as 300, but it kind of wanders around, so that's different. And like coming around to that power trigger and tracing it out, which I'm probably not going to be able to do relatively easily here. It's just the switch right there, S501, and that's just supposed to pull that line to ground. So it should either pull it to ground or not pull it to ground. So let's take the switch loose and see what's going on there. So when I take the switch loose and I ohm out between the switch contact and ground, we get a good solid yay or nay. Yeah, there's no resistance there. But yet when I apply my meter to that feed line, we get that weird climbing resistance there. The only other section that goes to is this reset line up here through the 15K and then through the reset voltage there. So it's kind of strange that all that's going on there. Then there's the 5-volt line that's only 170 ohms off ground. And that Q507 is a tiny little transistor, so it's not going to pull a bunch of current. And coincidentally, if you follow that 5-volt line, that very one, it's not the same one that drives the microprocessor. In fact, it comes all the way over here, and it feeds the video processor here. It feeds the sleep control, and it also feeds the reset. So, yeah, that's kind of bizarre. And that reset there on pin 9, let's check that voltage off ground again. So if I measure from pin 9 of IC104, I get 35K. And again, that line there, well actually I'd be going through the 100K resistor, so let's get on the other side of that first. So on the other side of our 162 or whatever it is, then we're back down to our 170 ohms. And that just doesn't seem right to me. There's just some gut sense I have about that doesn't seem right to me. So before R162, it's 170 ohms. After which, it's 35K to ground. And again, if we follow this line, it doesn't go very many other places. So even if it was shorted there, we'd be getting the 560 ohm C134 was shorted. And we'd be measuring the sleep pin with a little diode there, so that's probably not it. We just got to keep following, and then it goes up here to the frequency synthesizer. We could always lift that pin and see what happens. But that would mean the tuner wouldn't work very well, and the tuner does kind of sort of work. And then that goes back to the regulator, really. Yeah, that's a 9-volt line. That's not to be confused with the 5. So yeah, we come back here to that 5-volt line. So there's something else going on here, it's just not right. We measured the Zener diode, which was adequate. Or maybe it's just supposed to be a low load. It just doesn't seem right to me. There's just something wrong about that. So I need to just unhook and start tracing that line out a little bit better. Alright, it's time to stop chasing my tail and stop being an idiot. So I was so obsessed with that 5-volt line. I'm like, oh, it's 170 ohms or less than that or whatever. Well, if you do the Ohm's law calculation, what were you getting? 120, 130 ohms at 5 volts is more or less about 40 milliamperes of current. So that's negligible. And that feeds the PLL unit up here, which is part of the tuner that talks to the tuner. So we're going to ignore that. And we're going to go back to the important thing about this, and the thing that I really overlooked, which was the standby power supply. The 5.3 volt line that feeds not only the reset circuit, but the relay circuit that turns the machine on and off, and the memory circuit which holds things. Now, you may remember in the first video, we changed a 22 microfarad capacitor that was over here. This is C614, which I think is on another board, but I could be wrong. Oh, 616 and 615. 614's here somewhere. Anyways, that was definitely blown apart. However, we didn't change C611. And when I turn on or apply power to the chassis, I disconnected the side of the relay so we wouldn't get high voltage and shock the crap out of myself. The amount of hum on C611 is huge. And as you can see, what that does is that goes through that rectifier there, and is supposed to be regulated by the Zener diode D606. And our 5.3 volts there is really only about 2 volts, and it's dirty. So that would explain why nothing's working. So let's check C611 like a smart boy and figure out if that capacitor is alive or not. Because I'm betting it's not. It's one of these lovely United Chemicons which are all starting to fail and pee everywhere. Although I don't know if this one's peed yet or not. So let's go ahead and check this one. And there it is on the bottom of the board. And that solder there on the positive side looks kind of crappy and oxidized, like something got into it and ate it up. And when I put my probes on it with the capacitor wizard, nothing. It barely registers. Look at that needle just barely twitch on and off, on and off. So that cap is utterly dead. Ugh. Ignoring my own words. Power supply, power supply, power supply first, and then everything else afterwards. So let's replace that, and then let's check all the rest of these. It's a tedious process, but we gotta do it because, yeah, no more chasing my tail on this one. Alright, so let's remove this dude. He needs to come out. Oh, that's awesome. Where'd the lead go? So does that mean the leads are eaten away and this thing is just like not even in circuit anymore because it peed? Let me grab a hold of it. Oh yeah. Oh yeah, just ate the leads right off itself. You can see it bulging there at the bottom. Oh yeah. So take note, kids. These United Chemicon things are turning out to be like the purple Panasonic pissers, where they just bulge, pee, and kill themselves. But we have the solution. Let's stick a new one in there. I may even have to ream out the holes, because I still think there's chunks of capacitor lead in here. Let's see if we can. May have to get a pin and push them out. No, holes are clear at least. Alright, time to get in everybody's way and make you all dizzy. There's a nice brown spot where the capacitor peed out. Pretty much all these sets from the 80s and 90s are just turning out to be giant recap jobs. The 70s ones are touch and go. You can kind of do some spot repairs and troubleshooting, but all these ones that have the Matsushita caps in them and all these ones that have the United Chemicons in them, if I'm going to shake the camera now, they're all going bye-bye. Alright, so that's done. And that should definitely make our 5 volts a lot happier. So while we're in here, I'm definitely going to check the rest of the electrolytics. I'm not going to do that on camera because that's just way too much frickin' time. And maybe do some more spot resoldering. Most of this looks good. I definitely want to go over it more. It's like, you know, do it once, be done with it kind of thing. Alright, so we got everything resoldered up the way I wanted to, replaced a couple more questionable caps. So let's shove this thing back in the set and see if it performs like it should now, or at the very least keeps memory. I don't expect it to be perfect, but definitely a lot better than it was previously. So yeah, let's shove it back inside. Now if you're one of these people that wants the inside of the cabinet all cleaned up, now's a good time to do it, because you got the chassis out and you can see there's lots of room to work in here. So let's clean it up some. Alright, so cleaned up a little bit. Just stuck the stickers back in there willy-nilly. So let's put the chassis back in and hook it all up. Okie dokie. It's all back in a nice clean cabinet. Nice clean chassis. And now the big moment is to see if it actually is fixed. Alright, so here it is. You know what's weird? I plugged the thing in and it didn't turn on like it normally does. So that kind of worries me, but whatever. Let's see what it does instead. Not blaring sound. That's good. Channel 0. Alright. Yeah, let's see. Picture was at minimum. And it just says 0. How weird. So tuner's not working? Erase 0, add 0. Yeah, this is bizarre. At least before I could kind of sort of tune things. Let's get a signal hooked up to it and see what it thinks after that. Alright, so it looks like no matter what, we're on channel 0 and we can't make it go up or down, so that's a little weird. So time to check our work real quick here. Alright, so good news, I didn't do anything wrong. I just didn't know that you had to have the remote to set the channels for this thing. RTFM. So you have to dial the channel and then click add with the buttons on the front panel here, which requires that you have a functioning remote for this set. So it's good that I have the remote, because otherwise that wouldn't have happened. However, the remote's at the house, and so I just drug up a 90s early 2000s Sony TV remote, which actually performs the same functions. Oh yeah, and we gotta degauss that set now because I've been moving it around and it's magnetized. But it looks pretty good. There's a little bit of pincushion error. It's not too bad. There's no adjustment for it, so it is what it is. I replaced the capacitors in the circuit with no change. So that just is what it is. And then if we adjust our brightness, we got plenty of brightness. This is a good tube. Let's see what color bars look like now that the set is horribly magnetized. And you can see there that that's pretty ugly. So let's get the degaussing coil and see if we can clean that up. So this is our big degausser. I've got like 5 of these. Momentary power switch. I'm not going to do this holding the camera because I don't know what it's going to do to the camera, and probably not good things. So Basically, you energize the thing and go in a circular motion approaching the set and then going away from the set until the color bars are true. And then release the switch and you're good. And as we can see, one pass of that just cleaned that mess right up. So this thing's pretty solid. Let's hook it up to an actual TV signal and see how good it looks then. And there's some My Favorite Martian in color there. That's pretty cool. Sharpen the picture up a little bit. Yep, that works well. Brightness, color. Now look at those faucets. Look at that. That's some classy stuff. Vertical height is a little bit excessive. Let me adjust that real quick. The adjustment for that's buried in there, so I'm just going to do a quick tweak and then we'll look at it again. Alright, so we tweaked that a little bit and everything fits properly now without there being any underscan. Nice bright CRT. This thing's looking good, man. All the buttons work. And so without adding channels, all you get is 0 and 4 right now. So you have to manually add it with the remote. So hit the channel number, hit enter on the remote, and then hit add on the set. So yeah, that's not great, but you know, whatever. The set's working beautifully now, so I'm going to enjoy it for a bit, and then it's going to find a new home. So keep an eye out on eBay and the like, and you'll probably see this thing soon. So let's put it back together. Alright, so here it is all back together. It's doing pretty good. Nice bright picture. It's a little bit softer than I'm used to on a Trinitron. It's hard to tell on the camera, but even if you crank up the sharpness, the video response just looks like it could be better. But yeah, good black levels, really good contrast ratio. The camera's not picking it up because it's just a little bit on the bright side. But very cool, man. I turned the set off and I left it unplugged for a while, and it keeps its memory, so everything on it's fixed. So yeehaw. Anyways, hope you guys enjoyed this little tidbit, and more stuff to come.